So I want you to try to think about what do you need to make this thing happen. So this is just, it's a one ring becomes a two ring fused. So that's a, Robinson annulation reactions. So you need to think about, we got to create an innovate somewhere, right? And then so we need to find out what is a microacceptor with the alphabet saturated one. And then what goes where. So definitely either of these carbon, we're going to take the protons that are going to innovate. Is this carbon that one? Or this one? So that's something that you need to figure out. So I'll show you this 6-member ring, the carbonyl. That is kind of a goes here. These double bonds, that in alcohol with this, the water goes away. So this carbonyl is where this double bond is. So what it means is the alpha carbon is actually that one. So what we need is a alpha beta saturated one. This part is what we need for alpha beta saturated ketones. We got extra methyl groups. That's something that you got to remember in order to make this particular one. So how it goes, let's say you have a methoxide in the base, pick up the proton at the alpha position, you make an inolate. I kind of rotate it around because we have to make the ring display, so this carbonyl is kind of at that position makes it easier. Everything's going to be like that lined up if you draw this way. And then this will going to attack the alpha beta unsaturated ketones. So the structures need to be here. So double bond, and then carbonyl, and then you shouldn't forget about that side, not just methyl, it got to be ethyl, because we got the methyl group hanging out there. So these inolate go for the microadditions, and then you get the alpha beta unsaturated enol, and basically enol there. Enol will come and pick up the proton, so it's going to be ketone back. So we get ketone just right here. This is still in the solution of the base. So we can get this hydrogen at that position picked out by your base. Then you get the enolates right here, and then you got the carbonyl right there. So what happens is all the reaction basically happen. This comes, make a carbonyl, that attacks there and comes up. This is just an alkyl reaction. It becomes an OH. Extra methyl groups hanging out right that position, that's where we want. That's why it gotta be ethyl groups. If we don't have a methyl, then we don't need that. It could be a lower chain, and you're gonna substitute that position based on the, So that's why we need to figure out what you need in the end. But the that hydroxyl groups can be easily taken out as a water by picking up the base, come and then take it out and make a double bonds. So that will make this. So recognizing what you need is something that is associated with solving this type of problem.